We have shown in graphs 9.1 through 9.3 how we can derive different types of consumer demand curves for goods from the underlying optimization problem that consumers engage in. We can similarly show how we can derive labor supply curves from the underlying optimization problem that workers solve. Rather than putting goods on the two axes, we start by putting leisure on the horizontal axis and consumption, denominated in dollars, on the vertical axis. And for a worker, we typically assume that the worker's endowment bundle lies on the horizontal axis, where the worker has a certain amount of leisure endowment that he can choose to sell in the labor market. We begin by assuming an endowment of 60 hours of leisure per week and a wage of $20 per hour. This forms our initial blue budget constraint for the worker. We'll start with an original optimal bundle A, where the worker chooses to consume 20 hours of leisure, or in other words, the worker works for 40 hours a week. Now suppose the worker's wage goes up to $25 per hour. Then the budget constraint rotates through the endowment bundle outward to form the new magenta budget constraint. Notice that we're not drawing this exactly to scale here in order to make the graph a little bit clearer. Then suppose that the worker optimizes now at bundle C. To isolate the substitution effect, we take the final magenta budget constraint and shift it in parallel until it is tangent to the original indifference curve at bundle B. This gives us our green compensated budget, and we notice that as we go from the green budget to the magenta budget, we experience a strict increase in wealth without a change in opportunity costs, and as a result we consume more leisure and more of other goods. Thus both leisure and other goods are normal goods in this example. Next, we can use the same trick we used in our previous graphs to translate the information contained in the points in the upper graph to a graph in the middle, where we continue to keep leisure on the horizontal axis, but now put the wage on the vertical axis. Because we have the same good on the horizontal axis, the points will simply drop down, and the height of the points will be determined by the relevant wage for that point. Bundle A, for instance, occurs at the original low wage. Therefore, it'll drop down to the low wage in the middle graph, a wage of $20 per hour. Point C, on the other hand, occurs on the magenta budget constraint, which has a wage of $25 per hour. So when we drop point C down to the middle graph, it'll drop down to a wage of $25 per hour. Bundle B occurs on the compensated budget, which has the same slope as the magenta budget, and therefore also a wage of $25 per hour. So when point B drops down, it also drops to $25 per hour. The substitution effect is the move from A to B, and therefore tells the worker to take less leisure as his wage increases. The wealth effect is the move from B to C. It tells the worker to consume more leisure as his wage increases. And because bundle C lies to the right of bundle A, the wealth effect outweighs the substitution effect in this case, causing an overall increase in the leisure consumption for this worker as the wage increases. If we connect bundles A and C, we're estimating the relationship between the wage and the quantity of leisure demanded by this worker, all else being equal. Thus we're estimating what we could call the leisure demand curve for this worker. We're using bundles A and C because those are the bundles that represent the worker's actual behavior. Bundle B was simply hypothetical to isolate the substitution and wealth effects. What we've done so far is very similar to what we did for the consumer diagram in graph 9.3. The reason for that is that we're measuring the same thing on the horizontal axis in both the top and the middle graph. But now we'll change what we measure on the horizontal axis in the lower graph. Instead of measuring weekly leisure hours, we'll measure weekly labor hours. The amount of labor that is given to the market is the endowment of leisure minus the leisure consumption. Therefore, we can't simply drop points down from the middle to the lower graph. Instead, we have to think about what a particular leisure consumption means for the amount of labor that's actually supplied by the worker. Point A, for instance, tells us that this worker is taking 20 hours of leisure when the wage is $20 per hour. The worker starts with 60 hours of leisure, so if he's only consuming 20 hours, that means he's working for 40 hours. So when we take point A and transfer it to the lower graph, we are still working with a $20 per hour wage, but we now have to indicate that at that wage the worker is working for 40 hours a week. Similarly, point C in the middle graph tells us that the worker is consuming 25 hours of leisure when the wage has gone to $25 per hour. Thus, we know that the worker is working for 35 hours because he started with 60 hours and is taking 25 hours of leisure. At a wage of 25, the worker therefore works for 35 hours, which is what we have to indicate by point C in the lower graph. Point B in the middle graph occurs at a wage of $25 per hour and 10 hours of leisure, which is then equivalent in the lower graph to a wage of $25 per hour and labor hours of 50 hours per week. The substitution effect takes us from A to B and therefore points in the direction of more labor hours in the lower panel, just as it pointed in the direction of fewer leisure hours in the middle panel. The wealth effect, on the other hand, takes us from B to C and therefore points towards fewer labor hours in the lower graph, just as it pointed towards more leisure hours in the middle graph. When we now connect A and C in the lower graph, we get the relationship between the wage and the labor hours supplied by the worker. In other words, we've derived the labor supply curve for this worker. Again, we're using points A and C because those points represent the actual behavior of the worker at the low and the high wage. Point B was simply a hypothetical point to isolate the substitution and the wealth effect.